Yes, so hello everyone. Today we'll be discussing another question based on relative velocity. Okay, this question's title would be cat and dog question. So it's a famous question. This is also similar to velocity of approach like our previous video, but with a slight small change. Okay, let's see the question first. So as you can see on the board, a sitting cat in a field suddenly sees a standing dog. To save its life, the cat runs away in a straight horizontal line with a constant velocity of u. Without any time lag, the dog starts with velocity v, constant in magnitude and always directed towards the cat to catch it. Initially, v and u are perpendicular, as we can see in the diagram, and separation between the cat and the dog is d. Find the time after which the dog catches the cat. Okay, so initial separation is d. The cat is always moving in a straight line, and the dog would be continuously chasing it. Okay, so we say like this: this is the story of a stupid cat and a dog, right? Why stupid cat? Because if a dog is chasing a cat, right, a smart cat would go in a zigzag path, but we are having a cat which is actually moving in a straight line. Good for us, that makes our life easy. The question would be that much easier. Okay, so the cat will be always traveling like this. That's what the question is saying, always in the straight line. Okay, and what about the dog? The dog will try to always approach the cat with a constant speed v, but the direction of the dog can be changed. So like in the previous question, after some small duration of time, this is where the cat is and this is where the dog is. So now this is the separation between them. So now the dog would be moving in this direction. So this is now the new velocity v, right? But in the previous question, remember that square question where all of the 4k LMN were approaching each other, they're finally meeting at the center. In that, even this velocity would have changed its direction. But in this question, this velocity is constant in magnitude as well as direction, always remaining like that. And you can imagine what would happen. Further, the cat would be reaching here, the dog would now move in that direction. So we can say the path of the dog would look like almost in this way. This is how the dog would be chasing the cat and finally meeting the cat somewhere there. Okay, so now I want to find out the time. So what we can do here is, let us take a random position. Okay, let us say at some time t, like in the previous question, at some time t, the dog is here, and at that time, the cat is here. Cat is moving with the speed of u. The dog would be chasing it with the speed of v. Let us say the angle that this velocity makes with the horizontal is theta. If that is the case, then this line will also make an angle here of theta, like this, right? So now can I say velocity of approach here, how much it is? Velocity of approach is nothing but the velocity, the relative velocity along the line joining the two bodies. So we can say that this velocity is already along the line joining. Now this would be nothing but, that velocity would be u cos theta. So I have a u cos theta, I have a v approach velocity, I know. So now I can find out the time taken for them to catch. So we have to understand this. Initially, the separation between them was b, or d. As per the question, I think it is d. So initially the separation is d, and finally the separation will become 0 when it catches. Initially the time at that moment when they're starting is time t equal to 0, and finally the time would be t, right? So I cannot use directly the formula that time is equals to distance by speed and solve it like that, not possible, because here the velocity of approach that we use here, that velocity of approach is continuously changing with the angle. The v and the u is not changing, but the angle is continuously changing, so the velocity of approach would keep changing. But that's why we'll have to do it for a random moment at a given time. Okay, so let us try to find out at this moment t, how much is the what you can say, the time taken to cover a small distance in this direction, right? Let us say the distance right now here is a small distance of dx that has been covered, small distance dx. So what we can say now, we can write it as the dt, the time taken, is nothing but dx divided by, okay, what is the speed that we are having now? We can say v minus u cos theta. What is the dx? dx is the distance covered along this direction. So I can say currently the body is here. The cat and the dog would be covering a small distance of dx in this direction, like that. Okay, the approach, they will approach each other with a small distance of dx in the small interval of time dt. Now I am interested in finding the time, right? U and v, both of them are constant. Theta is variable, time is variable, and the dx keeps decreasing. So shall we write one equation? Shall we rearrange this like this, as dx is equals to v minus u cos theta dt. Okay. Now integrate this, because I am interested in finding the total time. So total time would be starting from 0 to some time t, and the total dx that has happened is starting from 0 up till x, starting from d until 0. So my integration would go from dx would go from d to 0, and this integration would be integration of v dt minus u integration of cos theta dt, where my time is the variable going from 0 to t. This also going from 0 to t. Okay. Now what we can do here is v is anyway constant. You can just take it out. What you get is vt minus, you will be getting here nothing, because you cannot integrate this, right? It's not possible to integrate because I don't know theta as a function of time yet. So integration not possible. I'm just putting it as it is, 0 to t. This value we can integrate all the dx's if I add, right? So basically it will be the total dx like that. So integration of x would be nothing but dx would be x. Limit if I put, it will become 0 minus d, like that. Okay. Now here also one thing is there, that this x is basically decreasing. Dx net is a decreasing thing, so I should be putting negative sign. I'll put at the end. Okay. So again, what we have got up till now, what is the thing that we have found? We have found out that how much time it is taking for the cat, for the dog to catch the cat. That's what we are doing right now, right? Okay, but we are stuck here. What's the problem now? I am not able to integrate this cos theta d theta. So that means I'll have to form some other relationship. This is not working. Okay, so if I can find this from some other relationship, and if I can substitute it there, then maybe I can proceed and solve the question. So what we can say further? We can say that the dog is actually finally catching the cat. So if dog is finally catching the cat, can I say that the distance covered by the cat, let us say here is where they are getting caught, right? So the distance covered by the cat in this time, let us say that distance is capital D, then that same distance should be also covered by the dog in that direction. That is why they are meeting there, right? So if horizontally distance are same, can I write one simple equation that u into t? What is t? T is the time in which the both of them catch each other, right? That is, dog catches the cat. Okay. So u into t, that is the distance covered by the cat in the t amount of time horizontally. Same distance should be also covered by who? The dog. But the problem with the dog is dog's velocity is continuously changing its direction. So which component of my velocity v is responsible for horizontal motion? Now? V cos theta, right? I can take a component of my velocity v in this direction. That will be v cos theta, and that is responsible for it. So can I say it is nothing but integration of v cos theta dt? That is the horizontal distance for the dog, and ut simply is the horizontal distance covered for the cat. So now from here I can get, see, I want to cos theta dt. I can readily get that because u is a constant. You can just take it out. This integration is also done for the limit of time t equal to 0 to t, like that. So from here I can get cos theta dt integration 0 to t will come out to be ut by v. Now if I substitute that in this equation, I think we'll be able to solve. So now what will I get if I substitute that? So this would become minus d equals to vt minus u. This value would come out to be ut by v. That's it. Okay. So I'll be getting d is equals to v square minus u square divided by v times of t. Okay. Where did the minus go? Remember I told you this dx is a decreasing value. So there should be a minus here. Okay, so that minus and minus would become plus. I'll get this, and finally I'm having the time as v by v square minus u square times d. Okay, so once again repeating, this is kind of a similar question to our previous one, right? But the difference is, in the previous question, the k, l, m and n, all of them were also changing their direction in the same way. So that's why that figure initially, which was a square, continued to remain a square, and that's why finding time was actually easier. No integration was required. Directly I could use this formula d divided by the v, velocity of approach, which was remaining constant because all of them were changing the direction. This time the problem is only the dog is changing the direction, cat is not doing that accordingly. So that's why I am getting a v which is continuously varying. My v is coming out to be v minus u cos theta, where theta is a variable. So I'll have to integrate that. So that's why I integrated to find the time. Okay, so on integrating, I was getting this. Now the problem was this term. I was not able to integrate. To get that value, I finally went to that concept. So what was that? Wherever the cat would be, finally when being caught, at that moment, the dog has also covered the same distance. So the distance covered by dog, which is this term, is equals to the distance covered by the cat. From there I got this value, I substituted, and I'm getting the final answer. So this is an important result. If you can remember this, it is good for directly if this question is asked in the examination, this cat and dog chasing question, you will be able to answer. Okay. Now there is a question which is similar to this. I will be showing that in the next video, where it is a cat and dog question, but it doesn't appear so. So when you look at that question for the first time, it doesn't come to your mind that, okay, this is a cat and dog. But the moment you think of it in a different way, the approach, if you try changing the approach, like for example, it's a relative concept. So the moment you change your reference frame, suddenly the question will convert into cat and dog. And if you know that it's cat and dog, directly you can use the formula and solve the question. Okay, so I hope you have understood this. So this would be also considered as a star question. Okay, it is a star question. Star question meaning what? Highly conceptual question. This one concept, one question, if you're solving, you'll be able to understand a concept on how to find out the time. So in different varieties of question, in the same fashion, the same step we'll be able to use. Okay, so if you understood it, so please make sure to comment in the box, comment and tell me that how you like the video, and if you like it, then please make sure to share it with your friends also. Okay, so until the next video, we'll stop here. Thank you.